Hey there, as a senior dev, I've seen a ton of code. And I can tell you, one of the biggest aha moments for junior devs is when they find a better way to handle collections. That's exactly what we're diving into today Java Streams. And trust me, this isn't just about learning a new tool, it's about a whole new way of thinking that's going to make your code so much cleaner and way more powerful. So let me ask you this. Ever feel like you're just writing the same loops over and over and over again? You know the drill, right? You get a list of stuff, and the task seems simple. Filter out a few things, change some others, get a final result. So what do? You reach for the old reliable for loop, sprinkle in an if statement, create a temporary variable, and yeah, it works. It gets the job done. But you're looking at your code, and you just get this feeling, ugh, there has to be a better way. Okay, take a look at this. I guarantee you've written this exact chunk of code or something super close to it like 100 times already. All we're doing is finding the even numbers in a list and adding them up. It's fine. It's explicit. We can read it. It works. We call this the imperative way of doing things. We're literally telling the computer every single step of how to do the job. But it works. So what's the problem? Well, what if we could kind of shift our whole mindset? Instead of writing out this detailed step-by-step recipe of how to get the sum, what if we could just declare what we want? This, my friend, is where Java streams come in and just totally change the game. All right, get ready for it, because here is the big aha moment. Just look at the difference here. On the left, that chunky for loop we just looked at, and on the right, the stream way. It's elegant. You can literally read it like a sentence. Take the numbers, create a stream, filter out everything that's not even, and then sum what's left. See? We're describing what we want, not getting bogged down in the how. And that brings us to this core idea, declarative programming. It's a fancy term, but all it means is you tell the computer what you want, not how to do it. With streams, you just say, hey, I want a filter, and you let Java worry about the messy details of looping and checking conditions. This is huge. It means less boilerplate code for you to write, which means fewer chances for silly mistakes like off-by-one errors. It frees up your brain to focus on the actual problem you're trying to solve. Okay, so how do you actually build one of these things? The best way I found to think about it is like a 3-step assembly line or a pipeline. Step 1, you need a source for your data, usually a list or something. Step 2, you run that data through a series of processing stations. These are called intermediate operations. And step 3, at the very end, you have a final step that gathers everything up and produces a result. That's your terminal operation. So let's build one right now. Step 1 is super easy. It's always the same. You just take your collection, your list, your set, whatever it is, and you call .stream on it. That's it. Boom. You've just opened the floodgates and created a pipeline for your data to start flowing through. Okay, pipeline's on. Now for the processing. Probably the most common operation you'll use is .filter. Think of it like a bouncer at a club. It looks at every single item coming down the pipeline and checks if it meets a certain condition. We give it a little function, a predicate, that returns either true or false. Here, n:(n%2 = 0 is our rule. If a number is even, it returns true, and the bouncer lets it in. If it's odd, nope, you're out. It gets discarded. Now this is where streams get really powerful. You can chain these operations together. A really common one to add after a filter is .map. So listen close. Filter removes things, right? Map transforms them. It takes every single element that made it past our bouncer and changes it into something new. In our case, we're taking each even number n and transforming it, or mapping it, to its square, n times n. And guess what? We can keep going. We can just keep adding more steps to our assembly line. What if our list of squared numbers might have some duplicates? No problem, just tack on .distinct. Want them all sorted nice and neat? Add .sorted. Do you see what's happening? We're building this really complex data pipeline, but the code is still clean and super easy to read. Okay, now for maybe the single most important concept to get about streams. It's kind of cool, actually. They're lazy. Yeah, lazy. All those steps we just defined, the filter, the map, the sort, none of them have actually run yet. Right now, our stream is just a blueprint, a plan. Nothing actually happens until you press the big go button. And that go button is called a terminal operation. In this case, .collect collectors.toList is our terminal op. It's the thing that finally says, okay, blueprint is ready. Execute the plan now, and give me a new list with all the results. And collect is not your only option for ending a stream. There's a bunch of them, depending on what you need. Just want to know how many items made it all the way through your pipeline? Use .count. Need to find the smallest or biggest value that came out the other end? There's .min and .max. Super handy. Let's make this super concrete. Imagine our starting list has these numbers in it, including a couple of duplicates. Okay, so first, .filter runs. It kicks out all the odd numbers. We're left with just the evens. Then .map takes each of those and squares them. Now we have a list of 4, 16, 36, and so on, including two 100s. Next, .distinct sees that duplicate 100 and throws one of them away. So now, if our final terminal operation was .count, what would the answer be? 6. See how that works? That's the pipeline in action. All right, before we finish up, let me give you a piece of senior dev wisdom. This is something I tell every single junior engineer when they first start getting excited about streams. It's about performance, and it's a really common trap to fall into. You're going to see .parallel stream eventually, and your brain is going to go, ooh, parallel, that must be faster. It is a very tempting trap. Look, it promises to use multiple threads to chew through your data. And for massive, truly huge data sets, yeah, it can be amazing. But, and this is the important part, for the kind of lists you work with 99% of the time, the extra work of managing all those threads actually makes it slower. So here's my advice, plain and simple. Always, always default to stream. Only think about parallel stream when you have millions of records. And even then, you better benchmark it to prove it's actually faster. And that brings us to the most critical takeaway of all. Look, you can watch me talk about this stuff all day long, but it's not going to sink in until you get your hands dirty. So here's my challenge to you. As soon as this is over, open up your editor, make a simple list, and just play. Try to filter it, try to map it, collect it into a new list, mess around, break it, fix it. That's the moment these ideas stop being abstract concepts and start becoming real tools you can use. Now go on, go write some elegant code.